Light may travel through a vacuum at the highest speed anything can ever reach, but it's still a finite speed. This means that it takes a while for light rays to travel between 2 points in space. The speed of light in space is about 300,000 kilometers per second. Now 300,000 kilometers is nearly the distance from the Earth to the Moon, and so it takes just over a second for light to travel from the Moon to the Earth. So when we look at the Moon, we're seeing it as it was just over a second ago.
Who hasn't thought about what it would be like to travel in time? The finite speed of light enables us to get close by allowing us to look back in time. When looking out into space, we just need to wait for the light from distant places to reach us, and it shows how things were when the light began its journey. Powerful instruments like Hubble have made it possible to look farther out and farther back than ever before. What cosmologists are seeing is simply astounding.
In the 1920s, astronomer Edwin Hubble discovered that most galaxies appear to be moving away from us at a rate proportional to their distance. The further away a galaxy is, the faster it appears to be moving away from us. This is due to the expansion of the universe.
That expansion began in a titanic explosion called the Big Bang many billions of years ago. The rate of expansion holds the key to estimating the age and size of the universe. This rate is called the Hubble constant. The age and size of the universe can be estimated by running the expansion backwards, until everything is compressed into that infinitely small point of energy from which the universe was generated. The top-ranked scientific justification for building Hubble was to determine the size and age of the universe. The quest to determine the Hubble constant precisely was headed by the Key Project team, a group of astronomers who used Hubble to look for remote, accurate milepost markers, a special class of stars called Cepheid variables. Cepheids have very stable and predictable brightness variations. The period of these variations depends strictly on the physical properties of the star, which can be used to determine their distance very effectively. For this reason, these stars are better known as standard candles. The Cepheids have been used as reliable stepping stones to make distance measurements for supernovae, which are much brighter than Cepheids and so can be seen at far greater distances.
Hubble has measured the light from supernova explosions more accurately than any other instrument, mostly due to its high resolution. From the ground, the image of a supernova generally blends in with the image of its host galaxy. Hubble can clearly distinguish the light from the two sources. Cepheids and supernovae have given a measure of the scale of the universe. Today we know the age of the universe to a much higher precision than ever before, around 14 billion years. For many years, astronomers have discussed whether the expansion of the universe would stop in some distant future, making the universe collapse in a fiery big crunch, or whether it would continue to expand ever more slowly. Combined observations of distant supernovae with Hubble and most of the world's top-class telescopes were used to measure distances to remote supernovae. And it looks like the expansion of our universe is nowhere near slowing down. Instead, it seems to be speeding up.
When Hubble was used to measure how the expansion of the universe has changed with time, it turned out quite surprisingly that during the first half of cosmic history, the expansion rate was actually slowing down. Then, A mysterious force, a sort of anti-gravity, made the universe hit the gas pedal, starting the acceleration we see today. This suggests an extraordinary fate for the universe, because it implies that the anti-gravity force is getting stronger all the time. If this continues, it will eventually overwhelm all gravity and catapult the universe into a super-fast acceleration that will shred everything into its constituent atoms. Cosmologists have called this nightmare scenario the Big Rip.